Okay. So our crash course, I'm Jongbin Zhang, and this is one of 3 sessions, the R basics. Here we're just going to cover like basically what stuff you can do with R and the building blocks of R, which are mostly vectors. Like I mentioned before, you're expected to have a working version of RStudio installed. If you don't have it, just remember you need to install R before you install RStudio to have everything working. R is the core program that is going to do the work for us, and RStudio is just this interface that lets you write R code in a convenient way. Right? Questions. You're given 3 sticks, right? And the sticks can be anywhere between a length of 0 and 1, let's say centimeters or inches. Okay? What is the probability that you can make a triangle out of these 3 sticks? The answer, obviously, is 1/2. But the goal for today is not to try and find the exact answer, but use R to simulate the situation enough times that you can kind of approximate what the proportion of times you get to make a triangle out of these 3 sticks. Okay? So we're going to try to learn the building blocks so we can achieve this by the end of this session. RStudio, if you haven't opened it yet, please do. This is what it should look like. So a few things of the basic workflows of R. Here, you get to write your script. Just think of it like Notepad or text editor or whatever it is you use. It's just a file that has plain text on it. And here at the bottom is something called the console. This is where our program is actually running, and it's where all the scripts get executed. Right? Usually the workflow is that you save your scripts, the stuff that you write, as a text file with the with like something .r, okay, the extension .r, and you can load that into this space and run it at the bottom, okay. And there are some neat shortcuts you can use. Here I wrote control. I think for Mac it's going to be command. So if you have stuff on your console and you want to clean it out, you can do control L in the console. What does that mean? Here I can write a bunch of gibberish. They're all errors because they're not real code, but then I can hit control L and that'll clean the console, in case you're OCD. And you can use control or command and a number to focus on a panel. The numbers I only usually use 1 and 2. So the top panel here is number 1. The bottom panel here is number 2. So I can do control 1, and then I can start writing some stuff here. I can do control 2 and start writing stuff here. It's just kind of convenient. From the text editing panel, from panel number 1, you can hit control enter to execute something. And what does that mean? Say I write 1 plus 1, and if I hit control, I'm still here on the text panel, and if I hit control enter, that line will automatically be pasted onto the console panel and executed, right? So you don't need to like copy and paste stuff. If I can do 2 lines, say I do 1 plus 2, which is more exciting, then I select everything and do control enter, then both lines get copied to the bottom, okay? I know these are like small things, but it makes your life easier in the future, trust me. And you can also comment stuff out in your script, which means you write something, but you don't run it, okay? And this is like, usually it's note to self, like explaining to future yourself, like why you did this now. So, for example, I can write this is a good example. Now if I run this, it's an error, so I don't want it to run. So what I would do is, the shortcut is Control-Shift-C. So I don't want to run this line, so I'll do Control-Shift-C, and it gets commented out. So if I just execute this entire block, you'll see that the commented line doesn't get executed, it's just ignored. And you'll see a lot of comments in the solution script that we give you, and it's also a good idea to write comments to yourself. There are a lot more things that you can do in RStudio if you're willing to explore, but I think these should cover your everyday scripting needs, at least for this class. All right. Now actually diving into R. So R is just a programming language, or the name of the program, that lets you run a bunch of computations, right? And when you're running your computations, you're doing that on a specific space inside your hard disk, okay? So it might be your desk, like the desktop, the stuff that you see on when you first open your operating system. It could be like under C/something documents if you're on Windows. And to see where you're running right now, you can go to the console here, clean that up, and you type get wd and open close parens. If you type that, it'll give you this path to where you're working, okay? And that's important because whenever you're trying to read data or when you're saving data, this is where that is going to go or come from, okay? So this is your working directory. If you want to change it, you can set the working directory with setwd. So, and usual traversing, like directory traversing conventions work here. What I mean by that is you can do something like ... and that'll take you one directory above, okay? So if I check where I am now with get wd, now I'm at home Zhongbin, which is one directory above where I was before, okay? I'll go back to temp. Note, you can always use this tilde as your home directory. For OS 10 users, I think that's something / your username, I'm not sure. For Windows, it's C users and then your username and documents. Also, a note to Windows users, if there are any. I know the convention in Windows is to use backslashes for directories, but in R, you should use forward slashes all the time, okay? Because backslashes they have different meaning, okay? So the basics, simple math operations, I think I've already shown you, but you can add stuff in R. So you can do stuff like 3 plus 11, good. You can also subtract, which is exciting. And then you can divide. If you haven't written code before, the convention for dividing on a computer is this /. So 3 divided by 11 would be written like this. Run that. And then multiplying is done with the star, the stuff that's above your number 8 on a QWERTY keyboard. And then you can raise to the power. So you can do 2 to the power of 10 with this caret sign, the little squiggly thing up. I think it's on your number 6. Okay? Cool. So that's how you do basic arithmetic. Next, you can assign things into variables, so you can actually store information into a letter or whatever you want, into a name. You can give things names. So if I want to assign something to A, the convention in R is to use this arrow. So it's like the pointy bracket with the dash. So if I do A is 12, you can see on the console nothing really happened. But here, if you look onto the right upper panel, you have environments, and it tells you that you have something called A, and it is assigned the value 12. So you can do like, yeah.
Sorry, I'm typing into the new untitled, but it's not showing up in the console. So I'm doing this.
Oh, it's Control Enter.
And do you have to click that each time?
Yeah, if you want to run something. So the thing is, you don't usually want to run something as soon as you type it. You want to type out a lot of stuff and then run it at a time. So, all right. I know it might be more natural to do something like this, like A equals 12, and it does work. There's no reason that you shouldn't do it, except for it's not conventional. Okay. Proponents of R like the arrow because you can also do crazy shit like this. You can say, oh, I want to push 12 into A, and that works. Obviously, it doesn't work with the equality sign, but nobody really writes code like this, so I don't see the point. But everybody in R, using R, writes code like this. So just good practice to do so. All right. You can write strings, which is like words, and also save those into a variable. Let's say S, and this is a string. I can run this, and here you can notice that S has become, this is a string. If you had any prior coding experience in C or those type languages, you might notice R, you don't declare any types. It doesn't care. So right now, S is a string. I can reassign a number to it, and it'll just work. It just replaces whatever was in S with what you're assigning now. Okay. And of course, you can always replace it with a different string, like, hey. So that works. So that is the very basics of using R, okay, assigning stuff to variables. And we've covered numbers and strings. Of course, you can also save the result of some computation. For example, result of 1 plus 1. And if I run that, then the result here is 2. You can also check it with result. Cool. Next is vectors. Now, vectors are pretty much the building blocks of R. And if you've been paying attention, even a number, like if I type 1, is actually a vector of size 1. It contains the number 1. So everything is a vector. And you can create your own vectors by using this function called C. For example, if I want to save a vector of 1, 2, 3 into the value x, I do x, arrow C, and 1, 2, 3. Then, x here is 1, 2, 3. You can also create a vector of, not numbers, strings. So this, that, and those. Then you have a vector y of this, that, and those. But you rarely type out your own vectors. You use some other method to create them. For example, one of the common ones is creating a sequence of numbers, like we did here with 1, 2, 3. And a function to do that is seq, short for sequence. And the syntax is you write where your sequence is going to start from, and where it's going to go to, and what it's going to go by. Okay, that's the syntax. And if you want to try a few things, for example, sequence from 1 to 100 maybe, and the by is the default is 1. So if I run this, it's going to give me numbers 1 to 100 by steps of 1, right? Like that. If I set the by to 10, then that's going to give me in steps of 10. Cool. It so happens that you create numbers of numbers that go by the step of 1 often enough that there's a shortcut for that, and it's just this colon. So if you want to create numbers from 1 to 100, you can just write 1 colon 100, and that does the same thing as just doing seq 100. Sometimes you want to repeat stuff, and the command for that is rep. So it's creating a vector of repeating the same value. So for example, it's the value and the number of reps. So if I want to repeat 13 2 times, I do rep 13 and 2, and it'll give me 2 13s. Okay. You can also obviously repeat strings. So yes, 3 times. Then you get yes, yes, yes. You can also repeat a vector, then it gives you a vector of concatenated vectors. So that means you can do repeat, see, Saturday and Sunday. And notice here, this part here is a vector in itself, right? And you want to repeat that vector, say 4 times. Then you get 4 Saturday, Sundays repeated. Okay. I think that covers. All right. Next is, given that this is an intro to applied stats class, you're probably going to be using some distributions, like numbers that you pluck out of a distribution. And to do that, you can use R and the name of the distribution. Like For example, if you want a uniform distribution, you can do R unif, and 0, 1 will give you, oops, oh, you have to give the number of observations you want first. 1. So this will give you one number from a uniform distribution of 0, 1. If you want 10, you just write 10. You can also do norm for a normal distribution, where in this case this is the mean and this is the standard deviation. And you can also do R pos for Poisson. I think you just did something like that. And there's also Rx if you want an exponential distribution. Yes?
So if you assign the normal distribution and the uniform distribution to a variable, is that storing the entire distribution then?
No, that's storing the values that you pluck out. So if I did something like x and then assign R norm, then x is those 10 values that I happen to get.
Okay.
Yeah. Okay, and this is probably a great time to introduce the documentation, because there's no way you're going to memorize all of this in the new, like just today. So it's always a good idea to read the documentation, like RTFM. And the way to pull up documentation in R is you go to the console, and then you do question mark, and then you type out what you want to know about. In this case, it's distributions with a capital D. So you can write distributions, and then you get this documentation, this help page here that tells you about all the distributions that you can use in base R, and explains here that like you can get the density function, cumulative function, quantiles, or random variable. And here there's like all these different distributions that you'll probably never use. So it helps to read the distributions, the docs. So if you want to learn more about the normal distribution, you go to dnorm here, and it'll tell you what these values are and what you can do with them. Okay? And in case you forget that the first one is the number of observations you want, second one is the mean, third is the standard deviation, etc. Also a note on how to read this documentation here. So it'll tell you in an R documentation, it'll give you a description of what it is you're looking at, and then the usage will give you an example of the function that you can use. And here it'll say R norm n. You don't really know what n is right now, and there's something mean equal to 0 and st equal to 1. When you read this in your mind, you should be thinking, oh, I have to provide an n, and then I can also choose to provide a mean and st, whatever they may be, and if I don't provide them, their defaults are set to 0 and 1 respectively. Okay? Now where do you learn what the n, mean, st mean? That is written out in the argument section that usually comes up right after the usage. And you can read here, oh, the n is the number of observations that I want. Now you understand what you can do with that function. And the details give you some details sometimes. Sometimes you won't. There are some documentation without the details. What you want to look at is a value. And this tells you what you get as a result from calling that function. So like, it'll tell you what is going to be saved to this x if you use an assignment with that function. Okay? So it's useful to know, and there you have it. Now let's say we have this vector, going back to vectors. How do we get a value out of a vector? So let's say I have this vector of 10, 11, 12, 13. Okay, that's x. Well, you can use square braces to index a single value. So if I want the first value that's saved in the vector x, you do x square braces 1. And if you run that, I'll get that 10. I can also do x square braces 4, and I'll get the fourth element. What happens if I try to get something that's not defined, like x number 5? We only have 4 elements. You'll get an NA, which is a special character in R saying that there's nothing there. You can also use negative indices, and in R, a negative index means you want everything but that index. So x of -1 will give you 3 elements, 11, 12, and 13. Okay, so that's without the first element. You can also index, now this can be a bit confusing, but you can index a vector with a vector of indices. Okay, what does that mean? Create a vector of the indexes that you want. So I'm going to call it ind. I'm going to assign to it a vector of, say I want the second and third element. So it'll be 2 and 3. Okay? And here, now, ind is 2, 3. It's just numbers. Now I want to use that to really index the vector x. So I'll do x and index it with the square braces, but instead of just giving it a number, I'm going to plug in that vector ind. And that will give me the second and third elements of x. Okay? Also, you can assign values into specific spots of a vector by assigning a value to an index. For example, from our x, say we want to change that first value into something else. We can just do x and index the first value, but then assign into it. So if I do change it to 101, then now our x is 101, 11, 12, 13. Okay? You can also change multiple values at a time. So remember we created ind to index the second and third elements of x, which was 11, 12. We have 2 values there. Say we want to assign new 2 values into it. Then we can just assign a new vector of, say, 2, 2, 2 and 3, 3, 3. And now our x is replaced like that. Okay? Next, remember if we do x5, we have nothing there. What if we want to put something there, right? You can do that simply by assigning to a non-existing index. So you can do, let's just assign a value of 555 to that. And now our x is length 5 with the 5th element being 555. All right, let me just some advanced indexing that might come in handy sometime. Let's say we now have a new x, and it's like 1 to 100, okay? And we just want the values in x that are greater than some number. One thing you can do in R is you can index using a vector of binary values, like binary being like true or false, right? And let me just give you an example. Let's create an index. Let's just see first, before that, let's see what happens if we do x greater than 95, okay? If I run that, I actually get this vector of a size 100 that tells me which elements of x are greater than 95, okay? So I can get that. I'll save that as an index now. So now index, ind, is just this size 100 vector where the value is only true if the corresponding value in x is greater than 95, right? And if I use that to index x, I will get the values in x that are greater than 95. Okay? So this is one way to just get the values inside a vector that meet a certain condition. Okay? Cool. Moving on to matrices. Let's say we have an x of values 1 to 12. I don't think I need the c there. Okay, so x is just numbers from 1 to 12. And I want to create a matrix that has 3 rows and 4 columns. There's a function called matrix, and the syntax is this. You give it a vector, and then the number of rows and the number of columns you want. So let's try that. We're going to use the vector x, capital X. We want 3 rows and 4 columns. And if I run that, and if I see what value A is, see it's using the vector of 1 to 12, and it created a matrix like this. Notice that it's creating everything column-wise, so it fills in the columns first. So you have 1, 2, 3, 4, 5, 6, going down. You can also index a matrix using the square braces. where the first item in the square braces gives you the row and the second item gives you the column. So if you do A, 3, 2, this will give you the third row and the second column, which here is 6. Yeah. You can leave either the column or the row empty if you want the entire column or row. For example, A and 2, comma will give you the entire second row, and A index comma 4 will give you the entire fourth column. That's basically how you would create a matrix. If you want to do more with creating matrices, you can always look up the docs. Here you can actually define whether you want to make it by row or not. And you can see the default is false, which is why it's created by columns. All right, now some vector operations, vector and matrix operations. So you can use t, the function t, to transpose stuff. So if we have this x here, which is a vector of 12, by default all vectors are considered column vectors, even though we're seeing it as a row. And if you want to make that x into a row vector, we can transpose it, and then it becomes this row. Notice how now it's kind of like a matrix. So I'm gonna make x smaller so it's easier to manage. Okay, so x is just 1 to 4 now, and we can make that into a row vector. You can do basic math in the unit of vectors. Remember that like vectors is the building blocks of R. So anything that you expect to happen with like vector manipulation, it works. Like you can add two vectors and it'll automatically do column-wise summation. You can also subtract, and that works too. You can raise the power of a vector, and what that means in R is that you're going to raise each element to that power. Okay. So most vector operations, if not all vector operations in R, are element-wise. So when you do something like x times x, this will just be element-wise multiplication. If you want to do the inner product, then you would do something like there's a percent star percent, and this would mean inner product in R. Okay, so x transpose x. Similar matrix operations. Let's just create a matrix A out of 1 to 4 and 2, 2. So this is a 2 by 2 matrix of 1, 2, 3, 4. Like that. And of course we can transpose that. And you can also add two matrices, which is again element-wise summation. You can also subtract. Again, raising to the power, it won't give you the power of the matrix, it gives you the power, element-wise power. And you can, now again, multiplying two matrices, it will give you the element-wise multiplication. And if you want real matrix multiplication, you have to do the percent star percent. Any questions? No? This might be obvious, but one warning on matrix multiplications, the dimensions have to make sense, right? Okay. I think we've already seen this, but you can do comparisons on two different vectors or matrices, and they all work element-wise. So if you do 1, 2, 3 is 2 equal signs checks for equality. So if you do C1, 2, 4, this gives you a new vector of true, true, false, saying, oh, the first elements, they are equal, the second elements are equal, the third element, not so much. You can do like all the regular stuff. Is it greater than, or is it less than? or is it less or equal to? All of that works, and it's all element-wise. The thing in R is to avoid for loops whenever possible. Okay. For example, if you want to get a mean of a vector, like the compulsion in other languages is to do something like if you have some x and 1 to 100, and I tell you, give me the mean of that vector, like all the values, then you, like coders, C coders will try to do something like for I in x, you want to get like some v initialized to 0, and you v plus xi, right? And then you, at the end of all that, you're going to do a v divided by the length, if I can spell, of x, right? Something like that. Never do that in R, okay? You have a vector x, just run mean of x. So there are a bunch of functions that work on a vector. Here you have mean, standard deviation, variance, get the maximum, minimum, median, get the sum, product. You can also get quantiles, and the length, and the range. The range gives you two values, a vector of two values, the first being the minimum and the second being the maximum value. Okay. Something less obvious is matrix functions. So if you want to sum the numbers in each row, you can do row sums. If you want to sum the numbers in each column, you do column sums. And you have the same thing for means and so forth. All right, next, let's take a look at a few functions. First, there are like a bunch of built-in functions like we've seen already, like the mean, or even the matrix is also a function. And here are other ones. So log gives you the log, x gives you the exponential, square root finds you the square root. Again, these work on entire vectors. The unit is vectors. So you do x vector. Instead of looping for each element, you just get the exponential of each value here, okay? Or log. Some string manipulations, if this is like, for me, it was the most frustrating part of R when I first learned it, is there isn't an obvious way to concatenate strings. Like you can't do stuff like string 1 plus string 2. That just won't work. So there's a special function that lets you stick strings together, and that's called paste. Who would have thought, right? So 1 plus 1 equals, say, and then you can actually paste a number as well, 1 plus 1. So remember, the stuff in the quote is strings. What's not are expressions. So R will evaluate the expression and get the string of that and paste it. So here we have 1 plus 1 equals 2. There's many more things you can do with paste. For example, you can, by default, you might notice here the separator between those values is a space. You can actually change that. So you can just copy paste that. Instead of spaces, say I just want equals, the equal sign. Okay. Then you can supply an argument called sep, S-E-P, and give it a string. In this case, I'm going to do space equals space. And you can see that the equal sign went here and here as well. If you're crazy about C-style formatting, which might be easier, you can also do sprintf and it works as expected. So you can do 1 plus 1 equals d 1 plus 1. If you don't know what this means, you don't have to, don't worry. But if you do and you like this, remember you can do this. All right. For me, the most popular use case for paste is to create a file name to save like intermediate results or whatever. So say I have a file name that I want. I'm going to call it some file name dot something. Okay, and I want to get the path to something, and I would use paste and then write out the path to someplace, and then add the file name. And if I run just this, oops, then notice there's a space here because by default the separator is a space, and you would think to do something like step is a blank, and then you get the file name. It so happens that I'm not the only one that does this a lot. A lot of people do it. So there's a shortcut for a non-space separator, and it's called paste 0. You can do just paste 0. It just saves you real estate on your screen. And then some people thought you do this so often, it might be useful to have another wrapper around it. So there's something called file.path, and you can write path without the forward slashes to some place, and then file name. And this will just put in the forward slashes for you. It gives you the same thing. It gives you a string to some path. Okay. So you might think here that when I write file.path that there's some object or whatever called file, and it happens to have a method called path. That is not true. The entire name of this function just happens to be file.path. You can actually name stuff with a dot inside it, which is just speaks to how archaic R is. So I can even name my variables like a dot something useless, like 1 to 100, and that will just be a vector. It's nothing. So the dot doesn't necessarily mean anything in R. So you can do it, but more lately it's become considered bad practice to do it. So try not to use dots in your variable names, even though you can. And just remember that the dot doesn't necessarily mean anything, so don't be confused when you see something like this. You'll find people write code like this, especially if you Google something for help and you're trying to figure out, oh, what does that dot mean? Like, where is this object? It's just a variable. Okay? Some functions for strings. So let's say I have some crazy string. Right, so that's S. And one obvious thing you might want to do is do character manipulation. Case manipulation. So you can do. There's something called toLower, which makes everything lowercase, and also obviously toUpper, which gives you all uppercase. Then R also has a bunch of generic functions which just work on a bunch of different things. So for example, if I have some object, in this case it's just going to be a vector, 1 to 100, there's a head function that gives you the first few elements of whatever object that is. Okay? And the default is 5. You can actually provide the number that you want, like that. And similarly, there is a tail function that will give you the last elements of an object. And I specifically say object here because it can be a data frame, for example, a data table. Then if you use head, you can use head on a data table or a data frame, and it'll give you the first 5 objects of first 5 rows of that data. Another one that you probably are going to use often is str. Unlike other naming conventions, it doesn't mean string, it means structure. So it gives you the structure of an object. In this case, it's just a vector of integers, so it tells us this is an integer with indices 1 to 100, and the first few values look like this. And also, a summary will give you a summary over an object. And again, this is going to be more useful when we're looking at data, like real data. But just to know that it exists. Here, since our object is just a vector of integers, it gives us like this summary of minimum value, the median, first, third quantiles, and the max. and the mean as well. Okay. So, control flow. There are if statements, and you do use them a fair amount. So you write them like this: if, and then in parens you give some kind of condition, and then you define a code block with curly braces, and then you give the stuff to run when that condition is true. And then you have else if, some other condition and stuff to do if that other condition is true. And then you can also have an optional else block. It's like a catch-all block. One thing to note about if blocks, it's generally considered bad to have stuff in, like have this catch-all else block, because that's going to be where stuff that you don't expect happen usually, right? So the best practice is to only have meaningful code for conditions that you define explicitly. And usually if you have an else block, just throw a warning or something. Okay, like say, oh, something that you didn't expect happened, we should stop, or something like that. Okay, that might not mean a lot to you now, but it'll help you in the future. Because unexpected shit happen in R. Again, loops. Now I'm gonna show you how to write loops, but again, you should try to avoid it as much as possible. I'm only mentioning it because there do exist cases where you need a loop, and especially in this class, at least once. So, how do you write loops? Just as simple as this. You write a for, and in parens, you give some index, you define some index that you're going to use, the iterator, and you write in, which is a keyword, and then you give a sequence. Then the for loop will assign sequentially each element in this sequence to this value, and you can use it inside your for loop. Example. So it's for I in just 1, 2, 3, right? So here, this 1 colon 3 will give me a sequence of 1, 2, 3, and I'm just assigning the I to that variable. And curly braces for a code block. Let's try to print paste iteration number I. If I run this block here, it gives me iteration number 1, 2, 3, one at a time. Okay. Similarly, you can write a while loop. I've never ever written a while loop other than in this exercise in R, but you can do it. So while, since we already have an I, and also notice that the I here is defined globally, so you can actually call it here again. So while I is greater than 0, greater than or equal to 0, you can run this code block and print paste I. Right? And as usual with all like while loops, you have to make sure that you actually change that condition, right? -1. Ta-da! So now we're going to talk about user-defined functions. User-defined functions in R is a first-class citizen, meaning that it's treated just like any other variable. You can create a function with the function, which takes the arguments that you want for your function. And you assign that new function to some name that you want your function to have. And within curly braces, you define or write the expressions of your function. Okay, in a function in R, you can use return to return some results of your function. So that is going to be the value of your function. The return call itself is optional. So by default, a function will just return the last object within that function, within the function's expression. But it's good to use the return to make it explicit exactly what you're returning. To call a function that you have declared, you just use the name of the function and give it the arguments that you want. So let's look at an example. If you recall, the goal of today's for this session is to simulate whether you can make a triangle out of 3 sticks. So it would be good to have a function where you give a vector of size 3, so the length of each stick, and the function will tell you whether you can make a triangle from those 3 sticks or not. So let's go back here, and I'm going to call the function isGood, and we're expecting as an input a vector of length 3. And we want to go iterate over each of those lengths. So I'm just going to use a for loop here. So for I in 1 to 3. And you want to check now if each of the ith lengths, so the length I, is greater than or equal to the sum of the other lengths. So everything but the index I. Now if this is true, we know that we cannot make a triangle out of the vector of 3. So we would return false. However, if our for loop ends and this condition never turned out to be true, that means we can indeed make a triangle out of this vector of 3. So we return true. Now when you have some input into your function and you kind of know what it should look like we do now, it's always good to check that the input makes sense before moving forward. So here we know that the vector should be of length 3. So before doing anything else, we check whether if the length of vec is not 3. And if this expression turns out to be true, so if we have a vector that's not size 3, we want to throw an error. We want to say something bad is happening. That's what we'll do with the command stop. And we'll say isGood requires vec of length 3. Scream. And what happens when you run this stop function is R throws an error, it stops whatever it's doing, and just gives this message. Okay? And we can run this block of code to create our function. Oops. So here, so we have this function isGood, and we can test it. So isGood, and give it a vector of 1 to 3, maybe, and false. You cannot make a triangle of 1 to 3. Or isGood, something that we can make a triangle of, under 4, 4, 4. That's true. What if we just give it a vector of length 2, and then we get this error, right? Lastly, I'm going to talk about apply. So I've been talking about how you shouldn't use for loops in R. Well then, how would you iterate over some object? And one of the ways is to use apply. So apply lets you use a function across some dimension of a matrix. And you can either use it on all the columns, on each column of the matrix, or on each row of the matrix. And that whether you're going to use the columns or the rows is defined by the margin. So for example, let's say we have this X, which is a matrix of 1 to 100, and it's 10 by 10. Okay, so it's a square matrix with all these values, and we want to find the variance for each row, for example. Then we would apply onto X, and for each row, so if we want to apply a function to each row, we would set the margin to 1. So 1. And the function is var, which gets the variance of a vector. Here then we have a size 10 vector, each corresponding to the variance of one row in X. Similarly, if we wanted to get the variance of each column, we could run this with a margin of 2, and that would give us the same results. Right, so next is an exercise. You now have all the tools you need to actually run this simulation. So I want everyone to take some time to compute this result. Your answer should be close to 0.5, and you can actually find the solutions in the next slides.